Hello, welcome in this video lecture. So, this lecture includes two important principles related to electron and its energy. That is de Broglie's hypothesis we have to discuss, and later on Heisenberg's uncertainty principle. Let's start with de Broglie's hypothesis. Now, in 1924, the scientist de Broglie put forth, suggested one special hypothesis, that is, the electrons are exist in two forms according to dual theory, that is, exist in the form of either wave-like or particle-like. So, whenever any radiation, light is considered, light is made up of from energetic particles. So, according to de Broglie's hypothesis, we have seen that radiation has dual behavior. It behaves like a wave and behave like a particle. So, this theory is put forth in 1924. Especially, he proposed that frequency and wavelength are associated with an electron's energy and momentum. Okay, frequency of any light radiation is associated with its frequency and wavelength depends on electron's energy and momentum. And according to the scientist de Broglie, wavelength of any radiation, which is denoted by the sign lambda. Lambda is the de Broglie's wavelength, and this wavelength or de Broglie's wavelength is equal to the distance between two crust and earth or trough of the wave motion. So, wavelength is correlated with electrons' energy, and energy of each proton is given by the equation E is equal to, see the equation, P into C, which is equal to H into V, where V is the velocity of light and H is the Planck's constant. So, E is equal to H mu is the normal equation, and which is further classified as H is the Planck's constant and mu is the velocity of light, or mu is the particular velocity, is equal to C upon lambda. Same equation, this equation is called as the de Broglie's equation, in which P is equal to energy upon Planck's constant and lambda is equal to H upon P. So, according to de Broglie's synthesis, remember the important assumption first. He assumed that any radiation contains energetic particle or electron. It behaves in the form of either wave or particle. First thing. Second, each wave and particle is having its own energy. For example, See the slide. Light behaves as a wave in the phenomenon of interference of diffraction and polarization. Light is composed from so many energy particles according to photoelectric effect and Compton effect. So, light has a dual nature, wave and particle. Remember this first statement. Light is exist in the form of either wave or particle. Now, light energy matter is also having dual nature, that is wave and particle. So, the wave is associated with matter is called as matter wave or de Broglie's wave. Now, wavelength of that particular light radiation having particle of mass m moving with the speed mu is given by wavelength is equal to h upon m into v. Focus on this equation. Wavelength of any radiation is explained by equation h upon m into mu. Okay, this is a wavelength of radiation or matter. Derivation of de Broglie's equation now we are going to see. Now, any light radiation according to Planck's theory, energy of photon of wavelength lambda is given by, first we see light is composed from energetic particles, and these energetic particles are nothing but photon. Questionable light, energetical particles, and these energetic particles are known as photon. Energy of photon of wavelength is denoted by letter lambda, is given by energy question दिली जाते according to Planck's constant or Planck's theory. Energy of any radiation is equal to h into c divided by wavelength. Remember, this is our first equation. See the equation first. E stands for energy of radiation. H is the Planck's constant. C is the velocity of light divided by lambda is nothing but wavelength of this radiation. So this is equation first. E is equal to h into c divided by lambda according to Planck's theory. Isn't it? Up to this I hope you are going to understand. Equation first, it explains the energy of radiation according to Planck's theory. Let as the E is the energy of equivalent particle of mass m, then from Einstein's mass energy relation we have. Now we have to deduce second equation. That is, if m is the mass of particle of that radiation, then energy is explained according to Einstein's mass energy relation, and it is explained by equation 2, that is E is equal to mc square. In that, E is the energy of light radiation, m is the mass of the particle, and c is the velocity of light. Now you have to focus on equation first and equation second. I will slowly repeat. Equation first represent energy of photons present in the radiation is equal to hc upon lambda. This is equation first according to which theory? Planck's theory. If m is the mass of particle present in the radiation, according to Einstein's energy equation, energy of radiation is equal to mc square. E is equal to mc square. It is a famous Einstein's energy equation. This is equation number 2. From equation 1 and 2, we get combination of equation 1 and 2, we get mc square is equal to sc upon lambda. Both equations are combined, or by rearranging this equation, lambda is equal to h upon mc, which is equal to h upon p, where p stands for mass into velocity of light, stands for momentum, that is p. So equation third becomes wavelength of light radiation is equal to h upon p. This is equation number 3, where p is the momentum of that particle. I hope that you have understood clearly equation 1, equation 2, and combination of 1 and 2 is equal to equation 3. So according to de Broglie's hypothesis, remember the equation 3, wavelength is equal to Planck's constant divided by momentum, or very simply, lambda wavelength is equal to Planck's constant divided by mass into velocity of light. This is a de Broglie's equation. So in short, I am going to repeat same what is de Broglie's hypothesis. De Broglie's hypothesis is nothing but any radiation possess energetic particles. These radiation behave like a wave as well as particles, and energy of radiation or wavelength of light radiation is always equal to lambda h lambda, which is equal to h upon p, where h is the Planck's constant, p is the momentum, and de Broglie's hypothesis is the combination of these two equations. That is Planck's theory. According to Planck's theory, energy is equal to Sc upon wavelength, first equation. And second equation is the if m is the mass of particles, then energy of radiation is always equal to E is equal to mc square. This is famous Einstein's equation of energy of any radiation. And hence, by combination of first and second, Planck's theory and Einstein's theory, we are getting de Broglie's hypothesis of wave and particle existence of radiation. So this is overall about de Broglie's hypothesis, and now we are moving towards another theory which is also well known, that is particularly Heisenberg's uncertainty principle, important one. Now see, uncertainty, everyone knows about this word. Uncertainty means no anything is fixed, static. We cannot say it is not certain. It is called as uncertainty. So the scientist Heisenberg put forth one theory regarding the position and momentum of electron or particle. That is, scientist Heisenberg put forth one theory which is important one, and this theory is related to particularly behavior of any energetic particle or electron in atom or matter. Now focus precisely. We are particularly focusing on electron. Consider particle as an electron. So according to scientist Heisenberg, He put forth a one probability assumption, that is, we cannot say that electron in the atom is having exact position in the orbit, or its perfect momentum of that electron in the atom. This is related with electron. For example, very simply, we are considering hydrogen as atom. What is the atomic number of hydrogen? 1. As hydrogen containing only one electron, it is continuously revolving in the orbit, circularly revolving in the orbit. We cannot say that the position of that single electron present in the hydrogen is fixed in the atom. It is continuously revolving. Means position is uncertain. At the same time, momentum of electron or any particle of the matter is also uncertain. Such kind of position and momentum uncertainty principle is put forth initially by the scientist Heisenberg, known as Heisenberg's uncertainty principle. So, this is very simple definition. Heisenberg's uncertainty principle states that the position of particle or electron in the matter or atom and precise momentum of electron or particle in the atom or matter is uncertain. We cannot say that it is having fixed position and momentum. So this principle is simply known as Heisenberg's uncertainty principle. This is theoretical part. Now, Heisenberg's uncertainty principle is explained by equation. See in the slide. Uncertainty position, that is x, delta x, change in uncertainty position, into uncertainty in momentum, that is x stands for position, p stands for momentum. Whenever the position and momentum is uncertain, then the equation is become uncertainty equal to Planck's constant h divided by 2 pi, h upon 2 pi. So this is the simple equation of Heisenberg's uncertainty. This principle applies for various equations like this: h upon twice pi px, where delta E energy, delta T P in this manner. This is further explanation related with uncertainty principle. So this is Heisenberg's uncertainty principle.